Welcome to my channel. I'm Zhan Xu. Let's look at the problem 21 in chapter 30. Chapter 30 is about inductance, electromagnetic oscillations, and AC circuits. There, we have a long straight wire, right? We need to find the magnetic energy stored per unit length inside this wire. The quantity given by this wire is the radius and the current. Now we can see, so we need to find the magnetic energy stored. So looks like we need to know the magnetic energy density and do integral with the volumes, right? So in this case, the magnetic density is B squared divided by 2 mu naught. So in this calculation, we can see the mu naught is a constant. So we need to find the B, magnetic field density, inside this wire. So very straightforward, we can consider Ampere's rule. So we can draw a circle. Look like this one, right? The magnetic field density dot the dl, the circle, right? B dot the dl, and do integral equal to the mu naught and the current enclosed. So the current enclosed, we can see the current is uniformly distributed in this wire. So we can write it, the enclosed current is the total current divided by total cross-sectional areas, pi r squared, this is capital R, then times the cross-sectional areas inside this circle, pi r squared, right, little r. And then simplify, we get it there. So now we look at the Ampere's rule, so we can write it in this way, right? So the integral for dl, in this case, is just the circle for this loop. So 2 pi r times b mu naught, and then the current enclosed is there. So we get it there. From this Ampere's rule, we can get a magnetic field density at the distance r from the center at this region, right? So now we input B in the magnetic density, magnetic energy density equation mu B, so we can get it there. So from this one, magnetic energy density, we can say this is a function of R, the small r. In this function, we can say this radius R is keep on changing in these wires, right? So that means we can split this wire in multiple loops. And in each loop, the wire's length is 2 pi r. The wire length is L, but this is circular. The length for this circular loop, 2 pi r, and how the width of this wire, the loop is dr. So in this case, we can get the dv. The split, the small fraction of these volumes is 2 pi r L dr. Now we input mu b and dv in this energy equation, this one, so we can get it there, right? And we do the integral from the 0 to capital R, we get the equation at there. Now we can find the magnetic energy stored per unit length, so use the energy stored U divided by the length L, so we can find the answer there. Thank you.